All right, so we're looking at inverse of functions. This is module 5.2. Just to kind of review some vocabulary. Domain are your x values, the input values. Range are y values, output values. One-to-one function pairs every input with exactly one output. So there are no outputs used more than once. So you won't see that y value repeat. Inverse relations reverses the input and the output values. So it flips the x and the y values. So an inverse takes all the domain values, puts them as the range, all the range, puts them as the domain. Something to note, an inverse may not be a function even if the original was a function. And if an inverse is not a function, it's called a relation. Remember, a relation is just a set of ordered pairs. So the notation for inverse is having this little -1 here by the function. And that's it. That's how we know that that's the inverse and not the function. Today's notes won't be as long as the day before, I promise. We're going to use a mapping diagram to complete the inverse of the function. Please make sure you got all those vocabulary words written down. I know they're a review, but we still need to make sure they're in our notes. So we're going to use the mapping diagram for the inverse of the function. We're going to complete it. We're going to determine if the function's a one-to-one or a many-to-one, which means the range doesn't repeat, or it may repeat. If it repeats, it's many-to-one. If it's no repeat, then it's one-to-one. And we'll explain our answers. So they're giving us the function. That's what's written in black. This is the domain. That's the range. It goes one-to-one. Notice our range does not repeat. And we're going to find the inverse. To find that inverse with that mapping diagram, and by the way, this is called a mapping diagram. It's showing how the domain and the range are related. To find that inverse, we simply take everything that's in the range, and we're going to write it here in the domain. So we get -3, -2, 2, and 1. Everything that's in the domain now goes in the range. So -4, 0, 1, 4. And we're going to change the arrows. So this -2 goes to -4, so it's going to go that way. -3 has to go to the 0. The 2 has to go to the 1, and the 1 has to go to the 4. That is a mapping diagram of the inverse. So this is your inverse. We've identified it as that. We need to decide if it's a one-to-one or if this is a many-to-one. And remember, we do this by looking at the range. Do we have any repeats? Do I have 2 of these values going to one of those? No. So this is a 1, 2, 1. And we simply say range does not repeat. That will work for our answer. Okay? You could also say no output is used more than once, which means inverse is a function, even though they didn't ask me to write that. I'm going to put that in. So there's kind of several wordings we can use to figure that out. All right, so we're going to look at another one, another mapping diagram. These are pretty basic, pretty easy. Number 2 up here. I have my domain as -4, 0, 1, 4. Range is -2, -3, and +2. Now, we need to define the inverse. Flip the domain and the range. So everything that's written here in the range is going to be written in the domain. So it's -2, -3, +2. My domain is going to be written in the range, -4, 0, 1, and 4. Now, I need to decide if this is a many-to-one, one-to-one, and what helps me with that is when I draw in those arrows. So my -2 has to go to the -4. My -3 is going to that 0. My 2 is going to go to the 1 and to the 4. So this is called a many-to-one because I have many values in the domain going to a 1 value in the range. So there's a repeat. So this is called a many-to-one. Whoops. I just slide it over there. So because it is a many-to-one, we two inputs here have the same output. That's a many-to-one. The function itself was not function itself, the original function, was not, or the original relation was not a function, but the inverse, we have one going to two different ones, it would actually still fall in as a function. And we'll talk more about that, and you should have talked about that with math too. But this is considered a many-to-one because I have many things going to the same value. It's like a repeat. Those little arrows say it's repeating. All right, so in this section, there's a lot of little things. So we're talking about being able to do the mapping and finding the inverse. Composition of two functions, g of x and f of x. Written as f of g of x reads f of g of x. It's a new function that uses the answer to this function as what I'm going to plug into f. And I know that sounds a little confusing, but we're going to practice it, and I promise it's really not super difficult, and it's kind of pretty easy, and it's just a little bit of math, and you guys aren't afraid of math. So here's my two functions. I have f of x is x plus 1, g of x is 2 times x. So this says to find the function f of g of x. Now what this tells me to do is it says to take 1 and plug it into g of x. So that means g of 1, that means take 2 times 1, that answer is 2. And I'm going to take that answer and plug it into my f of x. So that means f of 2 equals 2 plus 1, so my total answer for the problem is 3. So you're kind of doing things twice. You're going to take the 8, plug it into the g function, get that answer, plug it into the f function. So we're going to try another one. So g of 8 means 2 times 8. 2 times 8 is 16. I'm going to take that answer and plug that into the f function. So f of 16. Well, that means 16 plus 1, because it tells me to take whatever my x value is, add 1. That's 17. So my answer here is simply 17. Try it with a negative. We're going to take negative 2. We're going to plug it into the g value, or the g function. So g of negative 2 equals 2 times negative 2. That's negative 4. Take that answer. We're going to plug it into the f function. So f of negative 4 equals negative 4 plus 1. That's negative 3. So my answer is negative 3. See, a little bit of math, a lot of work. All right, last thing we need to be able to do today, and we're going to take you over here to this other board, is we need to find an inverse of a function given the original function. We're going to use composition, so what we just kind of practiced doing to show that they're inverses. Because it's like saying if I add 2 to some number and then I subtract 2, I should be back to where I started, and that's what an inverse should do. They should undo each other. So when we're done with our compositions, we should actually end up with x as an answer. And then we're going to graph the function and its inverse. And if you notice, I've already graphed the function because I already had it there. So first things first, we have to find the inverse. Finding an inverse of a function is pretty easy. I know a lot of you like steps, so let me write down a couple of steps for you. We're going to change f of x to y. Then we're going to switch the x and y value, and then we're going to solve for y. And then rewrite y as f negative 1 of x. Okay? So here we go. It's really not difficult. It sounds like it's a lot more than it should be. So I'm going to take my function. The first thing I'm going to do is make this a y value. Okay? Now that I've done that, I'm actually going to switch the x and the y. Because remember, when we write the equations, when we did that mapping diagram, we flipped our domain and range. So we're just going to rewrite this. I'm going to put a little negative 1 on the y because it's going to let me know that this is an inverse. And now I'm going to solve it for that y to the negative 1. And we'll make that a little negative 1. So that means I got to subtract 4 both sides. So x minus 4 equals 3, y to negative 1. that says 3 times y to the negative 1, so we're going to divide out our 3. So y to negative 1 equals x minus 4 all over 3. Please leave it in that format. Don't change this and try to rewrite it. We don't need improper mixed numbers and all that. So here, I get f to the negative 1 of x, because I'm going to rewrite it putting proper notation, x minus 4 over 3. There is my function. Now, I need to verify that function. So I need to do the composition. When I do the composition, it should come out as 0. So what that means is we actually need to plug one equation into the other. So here we go. We're going to take this right here, and I'm going to plug it in for x right there, and that's how we're going to verify it. Okay? So x is 3x plus 4, and then it says minus 4 divided by 3. So we're going to simplify this. 3x plus 4 minus 4. These two right here are going to cancel. So I get 3x, and that's just plus 0, divided by 3. 3x divided by 3 is simply x. That's what we should end up with. So that does mean that they are inverses every time you do it. And even if we've done it the other way, plugged this value in for x, we should have still gotten x out as a final answer. Now I need to graph this thing. To graph this thing, I'm going to split this up as 1/3 x minus 4/3. And to graph another marker. Here's the color. We'll do it in pink. It says my y-intercept is at negative 1 1/3, and that my slope is up 1 and over 3. Now I know some of you struggle when the slope is not right on a value because this is here. You simply just go up 1, so I'd be a little below here and over 3. And we are going to graph the function. And if I had a ruler, my lines would be nice and straight. Now, notice I have this black dotted line here. That's because if you truly have inverses, if I fold my graph along this dotted line, that y equals x line, my graph should line up. Now I know that I haven't quite used a ruler, so it might look a little funky, but they look pretty close to lining up. So that's how you tell by looking at a graph. I will see you tomorrow. Make sure you've done Cornell notes.